I want to begin with our resource recovery talk and with you, Anna Kleyböcker. Anna is with the KWB, Berlin Competence Center for Water. It is good to see you, Anne. The floor is yours. Let's get things started with the first presentation. Welcome, Anne.
Thank you very much. Yes, hello to everybody and welcome to my talk about water-smart industrial symbiosis in the context of circular economy and industrial wastewater. So as you have heard already today, 30% of the global population is affected by water stress. And this is also true for Europe. Here are 20% of the territory and also 30% of the total population affected. Climate change will increase the global water stress, and the World Resource Institute predicts a gap between water supply and demand of 56% in the next 7 years if we continue with our business as usual. And this is going to be very expensive. So, and also in Europe, the situation will get worse, especially in the western and southern parts. So what can we do? Can circular economy contribute to tackle the challenges? And how does circular economy work? In the middle of the graph, you see the wastewater. The wastewater can come from municipalities and industries, for example, pulp and paper, steel, food, beverage industries. And the wastewater is a valuable resource because we can recover water from it if we have the right technologies, and we can reuse it for irrigation, cooling processes, steam production, and cleaning. And it's not only water what we can recover. We also can recover different materials. We can use the wastewater as a basis to grow microalgae, and we can reuse industrial byproducts to treat our wastewater. We can recover different nutrients. We can recover the biomass contained in the wastewater to produce compost. And we can also recover high added value compounds. Now you might wonder, I don't know who of you is familiar with high added value compounds, but now you might wonder, what is it? And here, just to show you what this is, I brought you a table which shows on the left side the different fruits. And then you have a column where you can see the different compounds, which are the high value added compounds. Then you see the class, the properties and uses for those compounds. And very important, on the right side, you see the price per gram of one of those compounds. And you see if you have the right wastewater, it might contain quite a treasure. Besides material, our wastewater also contains energy in the form of heat and biomass, which we can use to produce biogas. We can combine it with the digestion of organic waste. This is called co-digestion. And we can valorize our biogas, producing electricity and heat. So now you might wonder, that's a nice concept, but how can it become a success? The idea is that first of all, you find cooperation partners. Partners who produce the wastewater and who need the recovered product, and who are also capable to operate the technologies. And if you have the right partners, you can create a win-win situation for everybody. And this we call a water-smart industrial symbiosis. And in our project in Ultimate, we have 9 of those water-smart industrial symbioses. And here the industrial sector cooperates together with the water sector to create this win-win situation. As industrial sectors, we have the agro-food, beverage, chemical and biotech industries. And as water sector, we have here different service providers. In our project, we showcase the symbiosis at 9 different case studies distributed across Europe and Israel. And here we develop and demonstrate 24 different technologies referring to water recovery, material recovery, and energy recovery. We are 28 partners, and now I would like to show you and present you 3 of our 9 case studies. One in which we focus on water recovery, another one where we focus on material recovery, and the third one where we focus on energy recovery. So let's start with our case study in Denmark. The case study is part of the very famous Kalundborg symbiosis. It's an industrial symbiosis which already exists more than 50 years. Here are 17 companies involved, and they reuse, recycle, and exchange their streams of water, energy, and materials. And they are quite successful. They have saved already a lot of CO2. They have recycled a lot of materials and also saved a lot of groundwater due to their symbiosis concept. And in Ultimate, they even want to extend it further. And here in Ultimate, we mainly cooperate with the biotech and pharmaceutical industry of this complex. And here on the left side in the scheme, you can see the symbol for the industry and also that it has its own wastewater treatment plant. And the effluent of this wastewater treatment plant goes or sent to the municipal wastewater treatment plant, where it's treated together with the municipal wastewater. And now the idea in Ultimate is that we implement a joint control system for both wastewater treatment plants so that we can allow to save chemicals and also to save energy. And in another step, we also want to reclaim water. And therefore, we investigated already different treatment trains, pre-treatment trains, to allow the recovery with a reverse osmosis. And what is kind of special in our project is that we have so-called communities of practice. Here, this is basically a workshop where all the stakeholders come together and discuss what do I have and what do I need. And here we identified that the power plant, the nearby power plant, needs cooling water. And we showed in our projects that we are capable to produce this cooling water with our treatment train. Another example is in Greece. Here we cooperate with the fruit processing industry, and they use groundwater to process their fruits and produce wastewater, which contains high added value products. Maybe you remember my table before I showed you. And in our project, we have developed a mobile pilot plant or wastewater treatment plant, where we on one hand treat the wastewater so that we can reclaim water for agricultural irrigation, but we also want to recover this high added value products. And this can then be reused in the food processing industry again as an additive. And in our third case study I want to show you today, it is located in Spain, in Lleida. We cooperate with a brewery. And before Ultimate, they had the conventional activated sludge system. And now in Ultimate, we investigate different biogas technologies as a pre-treatment, as an anaerobic pre-treatment. And here we have two advantages. On one hand, it's a pre-treatment so that we can reclaim our water later on after the full treatment, use it in the industry for cooling purposes or also for agricultural irrigation. And the other advantage is that we can produce biogas with our anaerobic treatment. And the biogas is further valorized in an oxide fuel cell. And here we can produce electricity, and it also delivers heat, which can be then reused in the brewery process again. So now you might think, yeah, that's quite nice, but what about my case? Which technologies can I apply? What does it cost? Is it environmentally friendly? And what is the legislative framework if I want to implement my concept? What is necessary? To answer those questions, I would like to invite you to visit our Water Europe marketplace. This is also part of our project. It's a platform which is hosted by Water Europe. And here you can find already 50 technologies which are related to circular economy. And you can also find the case studies where those technologies are applied. And you can also find contact data of the people who actually operate those technologies. And of course, you can also find our research results on this platform. We are not feeding this platform alone. We do it together with our sister projects, where you can see the logos in the lower part of the slide. And with this, I would like to thank you very much for your attention, and I'm happy to answer any question.
Jan, for this insightful presentation. Do we have any other questions for Anne? I'm going to probably ask you a couple myself, but I want to encourage you again to please use the chat function to ask questions to Anne and all our other speakers. There was also one question I feel about the availability of slides. So yes, those will be made available on our platform in the download section in the next couple of days. Anne, you talked about a joint control system between municipal and industrial wastewater. Who actually controls that?
Yeah, this is a very good question. It is, it's visible at both plants, at the municipal wastewater plant and at the industrial wastewater plant. And the idea is that they can see if from the industrial wastewater plant, treatment plant, if there comes, for example, a shock load of a lot of high organic fraction or a high nitrogen fraction, that the municipal wastewater treatment plant knows it in advance, and that they can already control their aeration system so that it's treated in the best way. So actually both can see it, and they need to have a very close relationship and to communicate a lot.
Okay, also, I was wondering regarding the pan-European wastewater or brownwater segment, is there a general analysis of the potential of it? Is that available? Is that something you're aware of?
The potential of, I did not really understand your question. The potential
The
of
overall like wastewater, what is the potential for, making it available for recycling it, for getting it back like into the circular economy? Do we know like what quantity we're talking about?
Yeah, this is a very good question. It's not so easy to answer. I also tried to find some numbers, and I found a paper which made an estimation what is the actual wastewater amount in Europe, and it is compared to the water use we had, it is around 20%. And if we have technologies which can recover from this wastewater our water, it can be in the range between 50% and at the best 90%. But then we have really a lot of technologies, and it also consumes a lot of energy. So if we have this, we could talk about 17%. But yeah, this is just an estimation based on papers I found.
Got it. Thank you very much, and I really appreciate your time and your expertise. Thank you for being on Blue Planet.